Now, the people that make these kits are called SparkFun. They're from Boulder, Colorado. Basically, a couple of friends got together and they realized it was really hard to teach electronics because nobody would create easy mix and match kits of just basic electronic components that students could actually learn about electronics. So they started a company to do that. And they have a lot of good information about electronics and how you get started on it. But what we're going to be looking at today is a breadboard. That's what this thing is. Now this breadboard is kind of nice. I wish we had some of these, but they're translucent, so that you can see inside the breadboard. And you can see how the breadboard, each of the holes are connected to each other. But we're going to look at that pattern and try to get an understanding of what a breadboard might look like, and how do you use it to do prototyping. Now there's lots of different types of breadboards. Here's some different styles. I also have some of these here in class as well. For example, if you're a professional electronic engineering, you do lots of prototyping, you might want to get yourself a really fancy board. So here's a huge breadboard. Let me just show the people here. It's just a monster breadboard with a lot of gizmos and posts and stuff, like a double breadboard. And it allows you to plug in power supply as well. So these are really nice for if you're going to go into electronics or electronic engineering. This is a larger breadboard. It's kind of standard setup. It's got power rails on either side, and you are able to actually take these breadboards and plug them into each other, or just connect them together, so you have a nice big prototyping surface for doing that. So this is a little bit larger. And then we have these small, if you just have small circuits where you're just doing like experiments like we're doing in class today, you can get one of these. It doesn't have the power rails on it, but it does have a little channel in the middle and some rows and connections. So what's nice about these is you can, if you run out of space while you're doing your prototyping, you can just hitch them together. And now you have twice as much room, and you just have a bunch of these. And you can make as big a breadboard as you like. So these are kind of handy as well. But all different sizes of breadboards, lots of different varieties, and you can see that in the pictures as well. You have the big one that I was telling you about, but the translucent ones I kind of like. I'd like to get one of those. The reason I like the translucent ones is so you can see the connections inside the breadboard. You can actually see it instead of trying to imagine it. All right. Now, as you get your kit, did you bring in the pen and the tape? Min, did you bring in the blue tape and the pen? Yeah, they're supposed to put their names on it, or put their names on it. Okay, excellent, excellent. Yeah, I just wasn't sure if that was getting done. Appreciate it. Boy, Min's on top of things. All right, so here we look at why we have breadboards. Take a look at this. When my father's an electronic engineer, when he had to prototype circuits, basically this is the way he had to do it. They basically had these nails sticking through a board, and they would wrap wire around it to make electrical connections. And if you can imagine doing prototyping this way, it would have been horrible. When my dad first started with the CIA, his job was to build like radio transmitters and receivers and bugs and things like that. And so there's this company called Heatkit, which allows you to build your own electronic equipment. And so they basically purchased every single Heatkit that was available and had my father build it so he could practice building electronic equipment. So he spent about 4 months just building all the tools he needed. He built his entire electronics lab from components. And then he used those components to build the things that the CIA asked him to build. But this is how they first started. Obviously, this isn't ideal for doing prototyping. And so you might ask, well, why do they call it a breadboard, right? Well, what you really need is just a flat surface to hitch something to. You have all these electronic components, but what do you do? So what they did was just take a breadboard, and then they would nail into the breadboard the connections, and they solder the wires to the nails, and and then you'd have a circuit. But obviously, this isn't an ideal way of doing prototyping. And you know, we talk about prototyping, but what does prototyping mean? It's basically you have an idea for some kind of thing you want to build, and you do the first stab at it. Say you don't have a breadboard, you have an actual piece of wood, and you want to say create this circuit that turns on this light with this switch. You could do it this way, I suppose. Again, it's not very elegant, but it does seem to work. So what instead of doing it this way, though, we'd rather have something a little bit less ugly and easier to work with. So let's take a look at what a modern breadboard is, or why would you use one? Okay. So an electronics breadboard, as opposed to the type that the sandwiches are made on, is actually referred to as a solderless breadboard. What is solder? You might ask that question. Good question. Well, what solder is it's a metal that you can melt at a relatively low temperature. When I say relatively low, it's still pretty high. We're talking about 400 degrees or so. But you can get a piece of metal to heat up to about 400 degrees. And then you can melt solder, and that melted solder conducts electricity. So you kind of like, it's kind of like you're welding two pieces of wire or two components together. Once the solder cools, it hardens into a solid metal, conducts electricity, and it's perfect for doing electronics. So, but the problem is there's all these fumes that you have to worry about. You can burn your fingers on the soldering iron. It's just kind of clunky. So, and it's not very quick. Some people can solder really fast, but that takes years of effort to figure out how to do that quickly. I'm getting better at it. It's been about 3 or 4 years, so I can solder things up pretty quickly. But it's easier, much easier to do your prototyping on a breadboard because you don't have to use the soldering iron in order to do that. So these are great units for making temporary circuits and prototyping, and they require absolutely no soldering, so you don't have to solder. Now, if you take my mechatronics class here at Southridge, we do learn how to do soldering. And so if you want to learn about how to actually build electronic circuits with solder, we get to do that in our mechatronics class. So prototyping is the process of testing out an idea by creating a preliminary model from which other forms are developed and copied. This is one of the most common uses for breadboards. If you aren't sure how a circuit will react given a set of parameters, you can build a prototype and test it out. Prototypes are really cool, especially in engineering. You can try things out, and you know, the first prototype is terrible. It doesn't work at all. Then you refine it, make a few changes, try again. And then you make a few more changes and you try again. And eventually you come up with a nice circuit that works the way you want it to. And then at that point, you can design your printed circuit board, put it in to get it manufactured, and then you can actually build that circuit and use it in an electronic component that you might want to build for yourself. Now, we had a student in class last year who created like an on-air sign so that he could tell people when he was recording in his bedroom for his like podcasts and stuff. And it was all over Bluetooth. And so his parents wouldn't be coming in the room interrupting him when he's in the middle of a video. Well, he decided to make this into a product and started selling it on Amazon. And he couldn't sell them fast enough, or he couldn't make them fast enough. He was selling every one he made. So he made a lot of money just doing that. And that's what engineering is all about. You find a need, you prototype it, you come up with a design, you maybe 3D print the case, and then you're in business, which is cool. All right, so here's a typical setup for a breadboard. You have components, all different types of components you can plug into the breadboard. Luckily, a lot of the components that you see are sized to fit in breadboards, as well as sized to fit in circuit boards. The distance between the legs of these integrated circuits are specifically designed to match the distance the holes are away from each other on the breadboard. So you have integrated circuits like those big black things right here. That's an integrated circuit. You have your LEDs, you have momentary switches here, other things. There's a capacitor, ceramic capacitor. Here's a resistor, another capacitor. This is a either a transistor or a silicon rectifier. So just by looking at the breadboard, you can see it can accept lots of different electronic components, which is great when you're doing prototyping. It really does help. All right, thank you very much. Yeah, we'll do this again tomorrow, same time, same place, and then we'll have. How many do we have left? Just quite. There's still some. You got. Okay. Okay, that's great. Yeah, cool. I thought there were a little bit more, so it's good to know. All right, so we have our kits. At least the people in class have our kits now. So tomorrow, if you're coming in, you'll get your kits tomorrow. And then if you're CDL, if you could just stop by the library sometime soon, so you can grab your kit, then everybody will have a kit, and then we can start building some circuits. So here's a fancy breadboard. This is one that you would use if you were in industry, like say electronic engineering, you're coming out with a prototype. What I like about these types of breadboards is they have these power posts where you can plug in your power supply. You can dial in with one of these fancy power supplies. And I'll bring one into class so that we can look at them. But you can set the amount of voltage you want, the amount of current that you want in this power supply. Say you lost a little wall wart for a gizmo, you don't know where the cord is. Well, if you have this power supply, a DC power supply, you can use that to power your piece of equipment that you lost the transformer for. These are really quite cool. I have tons of them, and we can learn. We'll learn how to use them, perhaps either in this class or in an upcoming class. Now, here you see this word DIP. Sounds kind of funny. DIP stands for dual inline package. Basically, it's an integrated circuit that has two rows of legs on it. One goes on one side of the channel, and the other legs go on the other side of the channel. And they're not electronically connected across the channel. That channel in the middle of the breadboard, that little groove in the middle of the breadboard, basically divides the breadboard in half. So electrical signals don't travel from one side of the breadboard to the other. That's almost like a dividing line between the two halves of the breadboard. But each of the rows on each side are connected. So if you see these lines here, what that's trying to show you is that those holes in the same row are connected electronically behind the scenes. So if you put in two components into that same row, it's like soldering them together, right? And there's 5 holes in each row. So you have lots of opportunities to plug in components together you don't have to solder them, you just put them in the same row. Ta-da, and now they're connected. Now on the side, so you have these big long power rails. Those are connected, those columns connected for the length of the entire breadboard. So it goes from one end to the other. You see these red and blue lines. Red typically is reserved for positive. Blue or black is reserved for negative or ground. And usually breadboards have them on both sides. So you have a power rail here, a power rail here, positive and negative on either side. So I like these kind of breadboards. Now here's an El Cheapo breadboard. Excuse me. It doesn't have excuse me. It doesn't have power rails on the side, but it does have the rows, and you see that channel in the middle is still being maintained. The breadboard is cut in half. One side doesn't talk to the other side. If you peel off the backing on the back of the breadboard, you'll actually see the little strips or the bottoms of the little clips, and you can see how they're not connected in the middle, but they are connected in the row on the one side. So they're not connected row to row, but those 5 things in the row are connected together. So this is a really good picture to have in your head when you're trying to do your prototyping, because you know if you stick 2 wires in the same row, you know that they're going to be connected. This is what the actual clips look like. They're like little pinchers, and what you do is you slip the little wire in between them, and it pinches the wire and makes an electrical connection. And ta-da! You have anything you plug in here, and will be connected to anything plugged in the other 4 spots. Okay, there's 5 holes per row. Notice these little clips. They're like little pinchers. They're ready to accept any wire that gets put inside of it. So that's a nice close-up look, and it's made of conductive material, so it makes an electrical connection when you plug it in. Now, you see this LED is inserted in the breadboard. Now, what you'll notice about LEDs is they have 2 leads coming out of it. That's not lead, that's lead coming out of the LED. One of the legs is short, and the other one's just a little bit longer. And the reason why they have make a difference with the LED is so that you can tell the polarity of the LED. LEDs are polarized, kind of like batteries. You know, a battery has a positive and a negative. Well, LEDs have the same thing. The short leg is negative, and the long leg is positive. If you get it backwards in a circuit, your LED won't light up. LED is a diode. It's a light emitting diode. Diodes only let electricity go in one direction, not the other way. So if you have your LED put in backwards, like if you build a circuit and the light's supposed to come on and the light's not on, you know what the first thing I do is? I turn around the LED to see if maybe I have it in backwards. So that's how you tell. So the short leg on an LED is negative. The long leg is positive. Now the power rail's on the outside. So here's a little bit bigger breadboard with the back peeled off. You'll notice that the rows are still separated, but on the sides, those are called the power rails. Kind of like the rails you'd see in like a train yard. One is positive and one is negative. And notice they're connected for the length of the breadboard, unless it's a super huge breadboard. If you have a 4-quadrant breadboard, then it cuts it in the middle of the 4-quadrant breadboard. But for this breadboard, these are connected the length way. Now, they're not connected from side to side. Like this positive rail is not connected to this positive rail. If you want them to be connected, you have to physically put a wire in both and connect one from the other, like a jumper wire. So it jumps across the breadboard and brings the power over to this side. Now, you'll also note on the breadboard that they have numbers. If you like to paint by numbers or build electronic circuits by numbers, say you don't understand how breadboards are connected, or you'd rather have a little chart that says, hey, stick this into a hole A1 and this into B3. It's kind of like playing Battleship. You can do it that way too. So you see there's letters along the top and there's numbers going down. It's kind of like a spreadsheet. In fact, I found a way to use a spreadsheet or use a spreadsheet to describe circuits. I can actually use spreadsheets to show how to build a circuit. And we might take a look at that later on. And it's something weird that I came up with. But to me, it looks like a spreadsheet. So red is usually for positive. Blue or black is it's usually for negative or ground. Now here are, I was telling you that they're not connected from side to side. So if you do want the positive power rail to be connected on the other side of the breadboard, then you have to put a jumper wire from one side to the other. So that's what's going on here. This is probably if I'm going to build any kind of prototype any circuit that's got any size whatsoever, the first thing I do is I connect the power rails. Okay? This is even before I connect any power to the breadboard. I just say, okay, I want anything I plug into here will be the same as plugging it over there. Basically, you're making them electronically equivalent. All right. There's also support for this dual inline package. A lot of chips that you see on boards and in electronics are packaged this way. They have leads on one side and leads on the other. And so the reason why the breadboard has that big channel in the middle is so it can support these integrated circuits. This is a very common packaging scheme for chips. Right now, there's because of the global pandemic, there's a real shortage of chips. There's whole production lines of trucks at the Ford plant that can't build trucks because they just don't have the chips. All the chips went into the Chromebooks that you have in front of you. every chip on the planet got used up for doing distance learning. And so they can't build some of their high-end trucks because they canceled all their orders when the pandemic started, thinking that no one would want to buy cars. And that was a mistake. And now the only companies building cars are the ones that didn't cancel the chip orders. The global economy is set up so that it's called just-in-time procurement. So you get your pieces that you need right when you need them. Problem is, if there's any hiccup in the global supply chain, then everything stops. Like right now, you cannot buy. Like for me, I'm trying to buy a synthesizer for my music studio, and the wait time is like 7 months before you get a new synthesizer. You just can't get them because all the chips again are in Chromebooks, things like that. So anyway, that's why that ravine is in there. It separates both halves of the integrated circuit and allows you to plug in stuff on either side. So rows and columns. So here that's talking about the letters. So the columns are lettered from A to J typically, and then the rows are numbered from 1 to however big the breadboard is. So if you need a step-by-step guide on how to build circuits, you do have a reference here written right on the breadboard. Kind of helps you build stuff. Now these binding posts, this allows you to plug in banana cables from a separate DC power supply. So you don't have to put batteries on, or say you're running at a weird voltage that batteries don't really support. You know, you have AA batteries or 1.5 volts. You have 9-volt batteries. You have 3-volt batteries, those coin batteries. But say you want to run at 5 volts. Where do you get your power from? Well, that's a really weird number, 5. You can't really, there's no 5-volt battery out there. So getting a board like this where you can dial in your voltage and your current in like a power supply, now you can do that on this kind of breadboard. Other features of breadboards is, you know, I was mentioning earlier that if you run out of room on some of these breadboards, you can just plug in some more of the same kind, and they fit into each other. They're like a little jigsaw puzzle. They fit right together. But again, between these sections of row, there's no electronic connections. It's just those 5 rows, or just those 5 columns in that row are connected. Now here's a larger breadboard. This is like that double breadboard I was telling you about. For those, that they usually stop the power rail in the middle of those. That's the only time they do that. Is when the breadboard is really large. That allows you to put one circuit on one side and maybe another circuit on the other side that work together, but they're not part of the same circuit. So you can prototype two different circuits. Or if you're in class, you can build one test circuit on one side and a different one over on this side, and they won't interact because of this break in the power rail right there. Now, how do you get power to your breadboard? Well, in our kits, I put in an Arduino in every kit. See, Arduino is kind of nice because it takes its power from a USB connection. Now, I tested this morning. In order to be able to program the Arduinos, we need a computer to do that. The computer that everybody has sitting in front of them, or everyone got one, is a Chromebook, right? So I had to figure out a way, how do we program the Arduinos using a Chromebook? And I figured out a way to do that. So you can use the power in your Chromebook, even before, say we're not even programming, we're just trying to get power to our breadboard. We can just plug it into our Chromebook. Our Chromebook will provide 5 volts of power to our breadboard. We just have to connect from the Arduino to the breadboard, and ta-da, we have 5 volts. And now we can build stuff with it. Doesn't even have to be programmed. The only thing you're using the Arduino for really is a power supply at that point. Okay, so here's the binding post. If you do have binding posts on your breadboards, which we don't, I was trying to find, I have a whole bunch of really nice breadboards with binding posts. Can't seem to find it. They're somewhere in the lab. I just don't know where they are. But you can just take a wire, put it through the hole, and just crimp it down a little thumb screws allows you to kind of smush it in that binding post, and then now you have a nice connection there going to your breadboard. If you have a benchtop power supply, like a DC power supply, variable power supply, this is how you plug it in. There's little banana plugs you just plug into it, and now you have power to the entire breadboard. So it just goes straight into the power rails. There's a negative goes into the blue, and then the positive goes into the red channel. Notice that these are jumpered to the other side. Now you're ready to start prototyping. You're going to need 2 wires though. You have the 2 wires coming out of the binding post, but you're going to have power coming in as well. So here's one where they're using just a standard DC power supply that you can plug this in, and then you can, it's called a barrel jack, and it allows you to get power into your board. There's also, you can actually buy these tiny little power supplies. Actually, I built my own. They're actually fun to build. Basically, it's a little power supply for your breadboard. You plug in a USB into it, and it smooths out the power. You'd be surprised how noisy the power is coming from a USB port. So if you want to kind of level that out and clean it up so that you have a nice clear signal coming into your breadboard, you can build one of these little power supplies for your breadboard. This is the first thing you probably build in an electronics class. If you go over to PCC and take their electronics class, this is what they have you build before the end of the class. And then you can use this little power supply for all of your experiments, and you can dial in what voltage you want with this switch right here. So anyway, these are kind of fun to build, and they're available from SparkFun as well. Okay, so here they have, if you were going to say buy your own setup so that you can start experimenting with electronics, you don't have to do this, but this is if you're interested. Get 330 ohm resistors, get a momentary push button switch. These 2 are included already in your kit. Here's a hookup wire assortment, basically different types of wires. And I put lots of wires in your kit. Mixed bag of LEDs. Each kit has its own set of LEDs. Power supply. The power supply we're going to use is our Arduino. And inside your kit, I also included USB cable. Now, make sure when you bring your kits back, the USB cable makes it back. A lot of people see a lot of utility in those USB cables and they hang on to them. But I'll be doing an inventory when you bring the kits back, and anything that's missing, you'll have to replace from the library. A breadboard, certainly, wire strippers if you're going to be making your own wires. But I put in these prototyping wires that are really nice. You don't have to do anything fancy with them. A breadboard power supply stick, or you can build your own, and then breakaway headers. Those are also good for building circuits, and there's some circuits we build in mechatronics to do that. Yeah. Yeah. Yeah, those little legs are not so great, and then it's not really. Yeah. Usually what I do is I put them in and I straddle the channel in the middle. But the problem is, which way do you orient it? That's the problem. You can't tell if there's 4. Usually on a switch, you only have a positive and negative, or not even a positive and negative. You just have 2 legs. With 4 legs, you don't know which ones are going to be connected when you push the buttons or not. So if it doesn't work the first time, you turn the button 90 degrees and then try it again. But you're right about that. The legs of the push buttons are a little bit wider than a wire, so sometimes they get stuck and they break off. So you got to be careful with those, and they're kind of challenging. Here's a fun circuit if you want to try this. If you have your breadboard here in class, is basically you connect the power from the Arduino to your breadboard and the power rails, and then you can make a little circuit that just this little push button. You press the button, the light comes on. Button's not pressed, the light goes off. Notice that you're getting power from over here. It goes through the LED, and then through the resistor, through this momentary switch, and then over to negative. One thing, and so you can see that ground is this one, and then VCC, that's your voltage. is connected to the red channel on this power supply. Now we don't have one of those power supplies, but we do have our Arduino. So all we have to do is take a line from the 5-volt coming out of the Arduino and plug it into the red power rail. So you could try out this circuit if you'd like. Now, typically, when say you've been taking electronics for a while and you're going to build an electronic circuit, they don't give you a picture like this to build. That's not what they give you. What they give you is this, called a schematic, and it describes the circuit to you. But you have to translate in your head. How do I translate from this schematic to something I plug into a breadboard? You have to make that translation in your head. The only way you're going to do that successfully is by knowing how a breadboard is connected to each other. All the holes in the breadboard are connected. Here's our ground. So basically, this is a schematic of what we're seeing here. They're exactly the same. But here they're using symbols, right? Here's our LED, right? Here's our resistor. The resistor, the squiggly line is a resistor. And then there's our momentary switch. There's the ground. Okay. All right. Here's that picture again. This is called the fritzing diagram. It's a really nice program if you want to actually design your own electronic circuits and you want to make them look nice. You can use fritzing. I think that's what they use in Tinkercad to make their diagrams as well. It's a nice library for doing that. Here's all the pieces in our kit. I didn't give you all the pieces. I just gave you the ones that we're going to need for the experiments we do. But basically, this is the kit we have. I didn't put the wheels and the motors in, or the servo motor, or the ultrasonic sensor, or the display. But you do have wires. You do have the 4 push buttons. You do have a potentiometer, a speaker. I put in 2 photoresistors. I also put in the USB cable and the breadboard, the Arduino Uno. So you don't have all the pieces, but you have some of the pieces. I didn't want to give out all the expensive pieces. So in case you might happen to lose the kit, it's not going to cost you $120 to replace. Okay. I left all the really expensive stuff out, other than the Arduino. We kind of need the Arduino, but everything else is there. All right, so that's a breadboard. So with our kits, we got our breadboard, we have our Arduino, which will be our power supply. We've got basic electronic components that we can use to build our circuits. I think we're set when it comes to learning about electronics. This is going to be fun. All right, so let's go back and look at this breadboard introduction circuit. This is once you get your kit, you can try this in Tinkercad land, or you can try it for real on your own breadboard. I would do both, actually. It says introducing the breadboard. I think that's the one we want to do. So these are called skill builders. It's out there on Tinkercad, just like our other lessons were. Now you should have 3 buttons, momentary switches. You actually have 4. There's a red one, a blue one, a green one, and a yellow one. So you can use any color here, doesn't really matter. Notice how the momentary switches are straddling the channel. And then you can just, the wire color doesn't matter. All the wires are equivalent. They just all conduct electricity. Now, sometimes you just generally, if you're coming from a power supply, you want to maybe use black for negative and red for positive, like you would see on jumper cables for your car, let's say. But you can make this circuit. What does this circuit do? That looks like a RGB LED. Problem is, I don't think our kits have RGB LEDs in them. Okay, so this is probably not the best circuit to use for that. You can take a look in your LED packet. There's an LED packet in your kit, and most LEDs only have 2 leads coming out, but there's one that's white that has 4 leads coming out of it. So let me hand those out. I'm going to hand those out right now, because I didn't think we were going to need them, but looks like we do. Yeah. Yeah, I think it'll work with two. Okay, as long as you have two, but I'll get you another button just in case. I did a little bit of checking each of the components, but obviously I missed a few. Okay, so these RGB LEDs are a little bit hard to find and they're kind of spendy. So you could put these in your kits. Now we can make this circuit, and I'll make sure I'll go in all the kits in the library and add one of these. Could you check in your packet though, in your LEDs, to make sure you don't already have one, because I don't want to run out. You've got one, because you might have one in the LED in the packet. You might pour them out. Did you take a look at your LED packet in the bottom there and see if you already have one? You already have one? Yeah, I just want to make sure. But if you don't have one, raise your hand and I'll come around and give you one. I forgot that a lot of people put them in the LED packet when they put it away. So people at home, if you could build this circuit using Tinkercad, then you get a chance to build it virtually, and then you'll have another opportunity once you get your kit to build it actually and see what happens to the colors when you press the button. All right. What does this circuit do? Well, let's try simulating it. If I press the button, this is an RGB LED. It's red, green, blue, and so it has a red line, a green line, a blue line, and then it has a ground. That's why it has four legs on it. So I guess that's the end of our lecture today. So if you could try to work on this just for fun, see if you can get this built using Tinkercad, and then once you get your kit, we're going to actually build it for real and see how it works. Instead of using a 9-volt battery, though, we're going to be using a 5-volt Arduino power supply. So we're going to have to change our resistor a little bit, right? Because if we change our power, that means we have different voltage, which means we have to use a resistor that doesn't resist as much, or your light's going to be kind of dim, right? But we'll figure that out and we'll do that math. Our topic tomorrow is Ohm's law. So we'll use Ohm's law to figure out what that resistor value needs to be given the new power supply. All right. Yeah, so if you are in CDL, if you could swing by the school in the next couple of days to pick up your kits, you can do it today if you'd like, till 3 o'clock. I think they said, no, 8 to 3:30. So 8 o'clock to 3:30 is when the library is open. You just come up to the front of the school, press the little button, little doorbell like thing. It'll ring the doorbell in the library, and one of the librarians will come out and just tell them what you need, and they'll get you one of these kits. I hope you have fun with them. It took me a while to get them all set up and make them work and all of that. So I think we'll have fun building some circuits, and we get to do it for real too. All right. Any other questions before I let the people at home log off?